All right, this one's a bit more complicated just because of the expression. So I need to prove, if I'm going to use alternating series, that this is decreasing. So that means that I need to show that my an plus 1 is less than my an. So I'm going to set that up. N plus 1 over n plus 1 plus 4 is n plus 5. Is that less than root n over n plus 4? Well, I'm going to start by squaring both sides because I want to get rid of the square roots, and if I have a number less than another number, if I square both values, that's still going to be true. So squaring both sides, I get n plus 1 over n squared plus 10n plus 25. Is that less than n over n squared plus 8n plus 16? So it's difficult to look at things this way and to determine whether it's less than. So I want to compare it to 0. So I'll move this to the other side, make a common denominator. The numerators are definitely going to be positive. So looking at the numerators, well, are the numerators definitely going to be positive? Maybe that's not actually true. Is it true? Have you guys looked at them? This is, what is this? Oh, it's n plus 5 squared. Of course that's positive because it's just shifted over 5. Shifted over 5 to the left, always greater than 0. Both of the denominators are positive, so I can move it to the other side. I'm going to put it together, making a common denominator. So I'm going to multiply my n plus 1 times this. I'm going to subtract n times this. So I'll have n plus 1 times n squared plus 8n plus 16. This is supposed to be n minus n times n squared plus 10n plus 25. And my question is that less than 0? Of course, you're always going to have your calculator on these papers. So I could put this into my calculator right now and just stop my algebra and determine if this is true. Or I can expand it. So I'm going to have n cubed here minus n cubed. That'll go away. I'll have 8n squared plus n squared is 9n squared. Minus 10n squared, so that's negative n squared. And now I'm going to have 16n plus 8n is 24n, minus 25n is negative n, and then I have 16, and that's it, so plus 16. And the question is that less than 0? So now I'm definitely going to use my calculator. I mean, I could think about completing the square, figuring out where the vertex is, but I can also just put it in my calculator and see that this is true for all n that are greater than 4. So my alternating series test only works when a to the n plus 1 is less than a to the n. So I've shown that a to the n plus 1 is less than a to the n only when n is greater than 4. So what I can do is I can take my original sum and I can rewrite it. So instead of having the sum from 1 to infinity, I'm going to say the sum from 1 to 4 of negative 1 root n over n plus 4 plus the sum from n equals 5 to infinity of root n over n plus 4. This bit converges just because it's a finite sum. So I could actually calculate out what those 4 terms are, add them up. This is going to converge by alternating series test. Therefore, overall, my entire sum from 1 to infinity converges.